Today we can talk about projectiles in physics. This is also a very important topic, projectiles. Here we can talk about this idea, horizontal projectile. Certain object can be projected horizontally with velocity u. Then you have to believe that until it reaches the ground, this horizontal velocity doesn't change. Then we have to assume here there is no air resistance against this motion. We can forget about that air resistance. Therefore, we can say that this horizontal velocity, or rather horizontal component of velocity, doesn't change until it reaches the ground. But when you consider vertical velocity, then we have to say that initial vertical velocity, it should be 0 at this point. Once it is projected horizontally, initial vertical velocity is 0. But with time, this vertical component of velocity increases. We know that acceleration due to gravity is acting vertically down always. Therefore, vertical velocity increases with time. Then you can believe that when it reaches the ground, it can attain a maximum vertical velocity there. Then you can understand here h, it is projected above the ground. This is the height h here, and we are talking about this range as well. Simply you can understand horizontal displacement. When you project somewhere here, then horizontally what should be the displacement? Horizontal displacement, the maximum horizontal displacement when the object reaches the ground, then this is known as a range. Then when you consider this type of horizontal projectile, you have to consider a range as well. When you consider horizontal motion, horizontally we can consider the velocity u, horizontal velocity u. We mentioned that it doesn't change with time. Therefore, we can say there is no acceleration horizontally. Therefore, we can apply only S equals ut horizontally, S equals ut. If you consider range r equals horizontal velocity u into time, or we can say this is the time taken to reach the ground, or we can say time of flight, time of flight. Therefore, yes, only S equal ut, this equation can be applied for this horizontal motion, since there is no acceleration. But when you consider vertical motion, this idea, vertical motion, then you can consider all the equation what we consider here. That is, if you consider this equation, v equals u plus at, this equation. Not only that, even s equals ut plus half it is squared, v squared equals u squared plus 2s, s equals u plus v by 2 into t you can consider. Here I have considered this equation for this motion vertically down. v equals u plus at. Anyway, at this point, when it strikes the ground, here I have taken velocity, vertical final velocity. When it reaches the ground, v equals initial vertical velocity, it is always 0 here, plus g, acceleration due to gravity, g into time, once again time of flight. Then we can find vertical velocity when it reaches the ground, v. If someone asks what should be the velocity of the object when it strikes the ground, actually it means, you can here clearly see, it is moving in this type of path, like this, like this, like this, this way, this way, this way, this way, this way, and like this. It is striking the ground in this type of direction, right? Basically, it won't strike like this. It is impossible like that. It is moving, 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 and strikes the ground in this direction. Along that direction, it is having certain velocity, I assume x, or that is, we can say, velocity of the object, or actually resultant velocity. We have considered two components, horizontal velocity and vertical velocity. Therefore, we can consider resultant velocity x. Simply, we can consider this type of vector diagram, the horizontal component and vertical component, vector addition, then you can get this resultant velocity here. Therefore, yes, according to Pythagoras, you can say the magnitude of this resultant velocity x equals u squared plus v squared square root. Sometimes we can talk about even this angle here, theta, or we can say theta to the horizontal. Here, yes, according to this diagram, it is simple, tan theta equals v over u, opposite over adjacent. You can find theta there. Theta equals tan inverse v over u. Therefore, when you consider this type of horizontal projectile, it is very, very important idea that its vertical velocity is 0. Vertical initial velocity is 0. Normally, in certain question, it is not mentioned, but when you hear that certain object is horizontally projected above the ground, then initial vertical velocity is 0. Therefore, this is very, very important point as far as these questions are concerned. Therefore, I like to discuss certain example with you. Right. Here it says a stone is projected horizontally with velocity 50 meters per second at a point above the ground, and it reaches the ground in 5 seconds. Find the range and velocity of the stone when it strikes the ground. Yeah. Then when you read this question, normally you have to highlight, you have to identify the important points. Here it says a stone is projected horizontally, projected horizontally. Then basically the hidden meaning is vertical initial velocity. Vertical initial velocity is 0. That's the idea. Then there is its horizontal component 50 meters per second. It it's okay, the horizontal velocity, and the time taken, or we can say time of flight, 5 seconds. The range, we know the ideal range, like that. That is the maximum horizontal displacement, range, and velocity of the storm. Velocity of the storm, like that. Then actually it means the resultant velocity. Resultant velocity when it strikes the ground. That idea. Therefore, we can consider horizontal motion. Horizontally, we know that velocity doesn't change until it reaches the ground. Therefore, S equal ut, r equals, anyway, range equals 50 velocity into time, or what do you say, time of flight, 5 seconds, 250 meters. That is the range for this motion. This is the distance. Basically, we consider the range, 250 meters. They ask that, this is the answer. And when we want to consider this resultant velocity, or rather when it reaches the ground, what should be the velocity? Resultant velocity. Horizontal component, yes, it is clear, 50 meters per second. Then we can talk about vertical velocity when it strikes the ground. Therefore, vertically you can apply V equals U plus AT, very famous relation. Then vertical velocity, V equals initial vertical velocity is 0 plus acceleration due to gravity, always 10 into 5. Therefore, V equals 50 meters per second. Here also 50, but it won't happen always. But according to this question, we'll get this vertical velocity also 50 meters per second. Therefore, we have to consider resultant velocity or vector addition here 50 horizontal velocity and vertical velocity, it is also 50. Therefore, according to geometry, then we can say the resultant velocity x equals 50 squared plus 50 squared square root, or 50 root 2, or we can simplify 70.7 meters per second. Yes, if you need to give this angle as well, basically when we talk about velocity, we are bound to talk about angle as well, but sometimes they do not worry about that. But anyway, here tan theta equals, yes, 50 over 50. It should be 1. Then tan theta equals 1. Then theta equals tan inverse 1. Yes, it is very famous value, 45 degrees. It will be better normally when we mention velocity, angle can be given. It is better. Yeah, anyway, this type of idea, you can try, you can practice this question continuously. Then it will be very easy. When you are familiar with these things, it is very easy process. It is not big idea. Physics is always very easy, but you have to practice. You have to practice. Yes, we can meet another day to discuss certain idea about physics. Goodbye.